On behalf of Institute for Energy Studies, I take immense pleasure in welcoming our today's speaker, Mr. N. Sivakumar sir. He is an engineering profession with self-motivated, hard-working, technically competent and result-oriented with a high degree of flexibility, creativity, resourcefulness, commitment and optimism. He is a versatile and competent professional with over 25 plus years of experience in the area of maintenance management, project management and manufacturing engineering. He graduated with BE EEE, ME Power System, Diploma in EEE at PSG Tech and MBA in HR. He is currently working as Manager Maintenance in ELGI Equipment Limited, a global leader in compressor manufacturing industry for the past 11 years. His past association includes Sulan Energy Limited, Tafe Limited, PSG Industrial Institute, and more. His area of skills and knowledge in the present and past assignments include maintenance management, energy management system, electrical panel production installation and commissioning, process improvements and quality improvement. He successfully facilitated the Quality Circle team and achieved Par Excellence Award at national level and state level competition. Awarded as CAPA champion in the organization level competition, and also he rewarded for most number of participants in shining CAPA competition in the organization, and he is appreciated for implementing TPM, JH and PF MEA across the organization. He also having hands-on experience and well practice in problem solving, root cause analysis, task achieving, quality improvement and productivity improvement. He is also having active participation and a key role in the implementing energy conservation projects, safety related projects and downtime reduction. With this introduction, I request you to deliver a talk on compressed air system, energy efficient processor. Over to you, sir.
Thank you, Sham, for a good introduction. Good morning, everyone. Thanks for joining with me for today's session. And I would like to share my knowledge and experience with you on this occasion organized by Institute of Energy Studies, Anna University. Hope this session will give you a refresh and enhance your knowledge. Actually, today the world is moving towards the sustainability development. So when we speak about the sustainability development, energy, we cannot avoid energy because energy is the most critical part in the sustainability development in the world. Before going to the energy efficiency practices, efficient practices, we'd like to know some basics. The basics, why we need to address the basics is without knowing the process, without knowing what is what, if we touches the problems, the energy efficiency cannot be measurable and cannot be effective. So the process, whatever the process, because the manufacturing process or in any process, financial process, even in a data acquisition, whatever the process in the our operation, so we know that there is an input and there is a desired output. That is a theoretical requirements, what we want to achieve the output. But even though there is a process, in the process, there is a losses. Definitely in every process, there is a losses. Unavoidable losses and there is a avoidable losses also. Sometimes unavoidable losses, we cannot we cannot avoid unavoidable. For example, induction motor, there is a magnetism current is compulsory required in order to operate, in order to deliver its output. But there will be a loss, avoidable losses, that is going to address in the energy efficiency part. And coming to the energy, what is energy conservation? Because in the late 90s and the beginning of 2000s, 20s, we hear about the energy conservation part. So everywhere there is a poster, there is a stickers, there is awareness classes, repressor training, more and more awareness session on energy conservation, and also lot of tips and energy saving tips are there. But later part, the energy efficiency, the term is emerging across the globe, across the organization. So wherever you go. So the difference is nothing because the both are interlinked with each other. But the only difference is the energy consumption. So we just reducing the energy consumption whenever it is not required, or some engineering control, some admin control, we are doing that. But in the energy efficiency part, so it is achieved through we are reducing the energy intensity. Intensity only we are using without compromising the process quality, product quality, and other specification of the product, and also the environmental factors. Sometimes, so see, in our classroom, or wherever office, or lighting to say. So whenever we see, whenever we go outside, we switch off the lights, fans, electrical equipments, whatever the things. That is conservation, one part of conservation. Some energy control, timer control, programmable control is doing. So that is also a little bit part of energy conservation activity. But energy efficiency is that in that particular room, what is the lux level is required? What is the lumens is required? Lumens for what? That is the efficacy has to be improved. So that's what the wattage will be reduced without compromising the lux level and also other environmental factors. So that is called energy efficiency. I hope we can move on to the next. And also one more thing, this compressors, actually a lot of, I hope you are aware of the basic the compressor, about the compressors, but I'm not like going details in the basics. Somehow, without knowing the basics of components of the not only compressors, I think you are going through many sessions, the useful sessions, the productive sessions these 2 days. Any basic components of any machineries and equipments or system or process or that assembly line. So without knowing the component, so you cannot measure. If you cannot measure, you cannot save the energy. So the energy efficiency is possible only you know the requirement of the process. What is the outcome of the process? Okay, that product metrics of the process, characteristics of the process. Okay, when we come to the air compressors, broadly it's divided into dynamic type and a positive displacement type. And whatever the applications we are using the compressors, actually the plant air applications, clean air, cleaning applications, dry air, and the instrumentations for breathing also in medicals, and the process. Many process industries, they are using air applications. Okay. So all these type of applications, so which compressors we need to choose? That is the major critical one. That is a significant part of the energy efficiency and also the energy efficient operation. So this is dynamic type, there is a centrifugal compressors. That is one. Actually, positive displacement is nothing but because we broadly used in nowadays industries. In early days, mostly the reciprocating and centrifugal compressors, but rotary screw compressors are very efficient one later part. Many major categories are there: oil injected and oil flooded, oil free and single acting, single stage. So radial, axial. This is bifurcating into many, but it depends on the factors. The factors deciding the your classification of compressors. The one is the type of drive. In the reciprocating compressors, there is a belt drive is there, and the rotary there is a gear coupling and the prime mover coupling. So many that type of drive and the cooling medium. So some compressors are water cooled, air cooled. Depends on the cooling medium we can divide into, and also number of stages. Depends on application and depends on requirement. So this number of stages are single stage and multi-stage. So these are them. And also the lubricated part, because oil flooded compressors are there. Rotary screw compressors, reciprocating are oil flooded, and oil free compressors are also there. Actually, there is a myth that oil free compressor means without oil. It's not. It's not actually, because there will be oil for lubrication, but the oil is separated from the air. That is the part we need to understand. If you have any, because can I ask you something in this two thing, dynamic and positive displacement? What is there is a constant pressure machine, there is a constant volume machine. Two types of them. So which one is called a constant pressure machine and which one is called a constant volume machine? If you are able to think, you can type it in our chat box. Otherwise, I will tell you. So in this positive displacement type, we are air inlet is being sent to the compressor part, that is air in that compressed air is compressed. Air is compressed. So by increasing the pressure and reducing the volume of air, that is compressed, and the outlet we discharge the air. Okay. So in that, what do you understand? This is the constant volume machine, positive displacement, and the dynamic type. So normally the kinetic energy, the centrifugal pumps and centrifugal operation, that same is applicable to the centrifugal compressors. This is called a constant pressure machine. But normally the dynamic type centrifugal compressors are used in the high demand requirement. For example, there's some medical, textile, some power plants, even in the some thermal power plants also. So huge demand is there. What is the huge demand? Above 12,000 CFM, cubic feet per minute. So if it is in the case, we can recommend for the centrifugal compressors. Then that will be the efficient one. That will be the efficient one. Rotary screw compressors are okay. Oil free is also, it has come up to 10,000 CFM. But the centrifugal, if there is a high demand is there, so centrifugal is the top one. And rotary screw compressors are 1000 CFM like that. So we can use the rotary screw compressors. A majority of industries are using the rotary screw compressors only. So now the market, the oil-free market is emerging, and also the water jet market is also emerging in it. So in compressed air system, there is a two parts are there. One is supply side and another is a demand side. So we should not look into the very only compressor side, because compressor is a main part. That is not only a deciding factor for the energy efficient operation of compressor air system. So compressor is one of the element in the compressor air system. Apart from this, so in the supply side, we have compressor and the filters and dryers, receivers like that. So in the demand side, that means in the assembly line or machine shop or your substation or power station or the process equipment side. So in this area, that is called as a demand side. So there is also some components are there. Okay. So the important parameters in air quality. So what are the important parameters? Why we are giving so much importance to the compressed air? Because many people think that compressed air is free, because compressors are always kept in the side of industries like power house, isn't it? So that time, why we need a compressed energy efficient compressors? So the important parameters in air quality are, the one is the dew point, and that moisture should not be there, and also the oil content should not be there. Temperature will be in an optimum level or in the low, and also the air should not contain the particulate matter. So for this, they have some filters are there, even in the pre-filter also in the suction side as well, because that is the most important part, but that is also a negligence part also. Many people neglect that area. So this primary filter and pre-filter, after filter, these are all the part of the supply side. Okay. Coming to the supply side, there is a compressor, and after that moisture separator, a vertical receiver or horizontal receiver also there, particulate filter, dryer, fine filter, and carbon filter. So we will get pure air. So this moisture separator, actually it will, there is a air which contains the liquid water and oil from air stream that needs to be separated. For this moisture separator is used. Sometimes we know that water vapor cannot be filtered out of air, but the water in a vapor state can only be removed by a dryer, right? So if it is a liquid, then it can be removed by moisture separator. So we need to understand water vapor cannot be removed by the moisture separator, but the water vapor in the form of liquid can be removed by the moisture separator. And coming to the receiver part, actually receiver always an important factor, because that needs to be complied to the standards ASME, American Society of Mechanical Engineers. That is, they have given some standards for the pressure vessels, this air receivers. So if there are two receivers type we have. One is the wet type, because we are connecting now here before dryer, that is called as a wet dryer, and after dryer if we connect the receiver, that is called dry receiver. So that is used for intermittent load applications, right? And this particulate filter, I think you know very well about the dirt and dust and other particles and pollen porous. This kind of airborne particles are being filtered out in this particulate matter. Dryer is more important, because sometimes we neglect the dryer, and also the capacity of the dryer also we are not aware, or we are not doing in a perfect way. So the dryer of two type, refrigerant and resonant. So this refrigerant type is mostly used in our industrial applications. The fine filter and carbon filter is also used after the dryer filter. So some moisture and oil content, and also the aerosol type of particles that can be filtered out in the hydrocarbon particles that can be filtered out in the fine filter and carbon filter. So we will get the pure air that can be applied to that can be sent to the machine shop or assembly line or the process or substation or wherever we want. So we would like to remember one thing. So this air quality, and we know that air quality is important. The same way, selection of these, see, we cannot make a negligence on these components: moisture separator, particulate filter, fine carbon filter, like that. So this needs to be adhered to the ISO 8573. So that is a standard that's given, because this filters needs to be selected based on this ISO standards. And also while designing or deciding the dryer, that size should be the matter. It is the matter, because we need to consider all the environment, all climatic conditions, all climatic conditions. So especially summertime, there is a high temperature in the compressed air system. So we need to consider that also, because it is the worst case, the worst design to be considered as a summertime. So that we need to keep in mind. So coming back to selection of compressors. Okay. We need to select the compressors before energy efficient, because it starts from the selection of compressor, each and every component selection, because energy efficient will not be at the end of the commissioning. It will be start from the planning part, right? So how do you select the compressors? Because we need to select the compressors based on the demand, because we have a demand base load, there will be a demand, because always there will be a load in the CFM, because in this diagram it is given liters per second. Normally we call it as a CFM. And the night average and the peak demand and day average, this all needs to be considered. And also the compressor, which type of compressor, because we know this dynamic type or positive displacement type, reciprocating, rotary, or centrifugal type. So in this, I think we have already discussed about this. Beyond this 12,000 say from our high demand area, we need to see, we don't have any, we never have a option. So we go for a centrifugal, then only that will be efficient for the effective operation of the plant as well as the efficiency part as well. And this right side, you can see there are many demands. Many demands are there. You have to choose. This is the easy way of designing the compressors without investing other accessories. So the one single machine, if the demand is almost stable, so you have to choose one single machine with a constant volume, and you can make it some small fine tuning is required. Pressure control is enough. And the two equal machines is required when there is a base load is there, but sometimes, so majority of the, for example, if the 8 hours operation, so from 10 o'clock to 4 o'clock only the demand is more. In the morning time and the evening time, there is no demand. So that time you can have two compressors, and also it can be used as a standby. So then three equal machines when you choose. So there will be a base load, and also the intermittent demand is there, but it's an intermittent load. Sometimes it comes some period duty, it is coming. So that time you can choose three equal machines, and one big machine and one small machines. So we have a base load is very high. Base load is very high, but there is an intermittent operation. Then and there is there. Then artificial demand is increased some in the process in operation in manufacturing. So that time we have to reset the compressor, one compressor, and we have to set it for the base load one compressor. So this is the selection process. But apart from this, duty operation, that is what we discussed here. The duty operation, that is more important, and the capacity. So what is the kilowatt? What is the kilowatt? That is more important. Actually, 1 kilowatt compressor, it produces approximately 4 to 5 CFM. That is the thumb rule. So actually, in CAGA, they are testing. It's a global level. They are the pioneer leader for designing the most efficient compressors. So they, as per them, 19 kilowatt per 100 CFM is the benchmark for them. And also one more thing we need to consider while selecting the compressors, oil carryover is the main problem in the compressor operations. So while after commissioning, so the customers and whoever the users, end users, are they're not knowing about much about the oil carryover. But the oil carryover, there is a standard. It should be less than 1 milligram per meter cube per meter cube. So that needs to be also we need to consider for that. Okay. And one more important factor, the pressure also important factor, because if I say 30 HP motor, 30 HP compressor, it produces 140 CFM, for example, let us consider. Because here, what is the pressure that decides the energy efficient operation and also the specific power consumption also. Actually, usually the 7-bar operation is majority of area. 7-bar is there. Suppose if you go beyond 7 bar, so there will be a changes in the energy efficient operation. So you need to consider pressure as well as the kilowatt and also quality of air. So which purpose you are going to use the compressor? That is more important. Based on that, you have to spend, you have to invest the money on this, right? You have to select on this. Okay, this is most important diagram in the compressor study, in the energy efficient part. Sankey diagram. So the military man Matthew or Sankey, he had used this diagram for the energy transfer in the diesel engines. So that can be applied to the compressor, but well applied. So when you see, as we discussed in the first slide process, so here 100 kilowatt is the input power we are giving to the compressor. So inside the compressor, what happened? What is happening? There is a heat dissipation. There is a compression of air. due to compression of air, the heat will be produced. So the heat of compression and also the mechanical losses will be there. So mechanical losses is unavoidable losses. So there will be a gear arrangements are there, bearings and the rotor or piston. So these activity, this process is going on inside the compressors in the air or the cylinder. So the useful output, just see only 15%. What is it? See, 100 kilowatt we are applying to the input power. So only 15 kilowatt is the output power. In the 15 kilowatt output power only we are generating the air for our use. Even in the 15%, we are wasting the air in some many artificial demand, other due to various reasons. So it has been getting wasted. So we need to address this 15% as well as so after some awareness and some technological changes and energy efficiency is a main mantra in the environment report. So this 80% is also important on that. So 80% that can also be utilized. So where this 80% heat of compression is coming? Where this 80% is coming? See, we have a compressor. In the compressor, there is a suction of air. The air is sent to the air end or piston or something. There will be a compressed air. The temperature will be raised. So we need to cool the temperature. We need to cool the temperature. Then only we will have an efficient operation and also the air quality. Otherwise, water and other unwanted things will be formed. So in this, there is a intercooler and aftercooler arrangements are there inside the compressors. So this will reduce the temperature, thereby increasing the efficient operation of the compressor. This aftercooler, so again, this water and other things, this will be removed from the compressor. So from this oil cooler, almost 70 to 75% of energy heat dissipation is coming out. So for oil cooler, we are using water cooled or air cooled. So in that area, if we apply waste heat recovery technology in an effective way, so we will make use of this heat of the compression in a better way. So that is an opportunity. Okay, so we have opportunity here, heat of compression and also 50% wasted air. So these are the opportunities we have. Okay. And coming to life cycle cost, so we need to consider life cycle cost of any equipment machineries. Normally, the compressors, you can see the compressors or machineries are the asset cost because this is the costliest asset in any organization. Because you see the energy cost, that is a very hidden only because every month the EB bill is going to finance. But energy cost, one of the element is the compressor energy. But that will be hidden if you are not addressing properly. The initial cost you see only 10%. So combining with energy cost and maintenance cost, put together 90% is the thing. So we need to address both. Maintenance cost, suppose if you do proper maintenance, so that energy efficient also will be improved. In the maintenance cost, it's inevitable that we need to spend the consumables cash. Definitely we need to do that. So unless otherwise, if we spend the proper cost to the maintenance, so energy cost will be more and also we will not achieve energy efficient, right? So the maintenance cost is must, but we can avoid the downtime, unforeseen downtimes, and also the major failures and all those airing season like that we can avoid with the good maintenance practices. Immediately, this energy cost, if you want to reduce, and also this maintenance cost, immediately the two options in front of us. One is the sizing of the compressors. Suppose correct sizing of compressors, immediately 20% of the energy saving is possible. See, normally we do so without analyzing the process, without analyzing the process requirements, product requirements, we are choosing the compressors in a like that. So that needs to be addressed. So oversized compressors we should not do by selecting it. So if we want to further expansion in the factory or the productivity due to productivity increase, so we need to go for some options. Or also we need to forecast the what is our organizations or our power plants expansion in the future. That we need to consider. But you have some cushion on the sizing, but you cannot keep more than 15%, 10%, 15%, right? So that should be, so otherwise you have to improve the process effectively. Instead of increasing the size of the compressor, you have to concentrate on the process. So how to make effective way the process elements in the process cycle time. So this kind of improvements you need to do. The second one is the right-sized compressor. Both are same, but the right-sized compressor means, so you have to decide, but select from clauses: capacity, quality, air quality, and duty, operation. So this kind of points to be remembered while selecting the compressors. Okay, we want to achieve the energy efficient compressors and also the compressed air system. So if we address only compressor elements and compressor, that will not solve our purpose. This is the demand side we need to do. That is all. That is very, very important, because we get only 50% compressed air for the manufacturing. Another 50% is going waste, ineffective. So the air leakage. So the most negligent part in the industries, in the plants. So when you are walking to the through plant, will you observe air leakages? Even if you observe the air leakages, what will you do? Sometimes that air sound is getting familiar. We get familiar with air sounds. Even though if suppose the sound is huge, enormous sound is there, then only for safety purpose we are going there and see what is to be done like that. Otherwise, small air leakages unnoticed, no man lands. That needs to be addressed in a proper way, because nothing else. There's a no cost and low hanging fruits opportunities. You just simply do some corrections: cleaning, lubrication, inspection, and tightening. That's all. And FRS, once you fitter, once you commission, that's all. No one is bothering sometimes, because we cannot do that, but also you have to do air leakage management. So you see, 25%, minimum 25% is there. Even some industries, some plants, more than that. More than that. And the artificial demand is nothing but you are increasing the pressure without knowing anything, because you are increasing the compressor pressure, because there is a pressure drop in the end. So the production people asking, that end user is asking, sir, here so many drops are there. Only I am getting 5 bar pressure, 4.5%. What do you do? What your technicians will do? He will raise the pressure in the compressor. Okay, that pressure drop will be managed. So this is also a very, very abnormal thing. And also we need to take care of these things. This will impact on huge energy cost. So in the energy bill, definitely, because every industry, every organization, every plant, ultimate goal is the business profit, right? Business we need to, because we need to build up our business in the name of profit and also branding and also sustenance. We need to keep moving on the business. So the cost is one of the element to make our business in a very impact way. So that purpose, you need to address the cost. In the addressing the cost, energy cost is so important. While addressing the energy cost, compressor energy is most important. And inappropriate use, that we can see the people working in machineries and equipment and assembly line. After end of the shift, they will do some bathing with the compressor. Have you seen? So this is an inappropriate usage because that the compressed air is not free. So you can use some other things for cleaning purpose, and also floor cleaning. They are using these compressors without knowing or unaware of this. Some awareness is not there. So we need to make aware of them. So adherence is very important. So 5 to 10% is not a small thing. Just not 5 to 10%. So that needs to be okay. These are the wastages we are finding out. These are the wastages we are finding out. Okay. While finding these wastages, so we need to address these wastages in order to achieve the energy efficiency. So we need to find out the opportunities. So what are the opportunities? So while thinking about the opportunities, we have many opportunities. We can generate ideas and we can know about this from the data analysis like that. So okay, we have opportunities. How to address the energy efficient, right? How to address the energy efficient. So before knowing the energy efficient opportunities, we would like to know what is efficiency in the compressor. What is efficiency in the compressor? Okay, so this efficiency are termed as very isothermal efficiency and many terms are there. So one of the thing is the volumetric efficiency. This volumetric efficiency is nothing but free air delivered and compressor displacement. This is the ratio between the two. So in this, you can see compressor displacement because we will see the free air delivered. What is that? Because that is nothing but the discharge air we are getting at the end of the compressor before going into the shop floor. So this compressor displacement, there you can see the formula y squared by 4 L into S into lambda into L, right? There you can see directly compressor speed, yes. Others are we can't do in a regular way by doing energy efficient operations. So only thing is that compressor speed. By varying the compressor speed, you can vary the volume. So that this we can do. By varying the volume, you can save the energy. This, but many other options are there available. So we can see one by one. In the free air delivery, that is the inlet condition because the free air delivery is measured in the inlet condition. What is inlet condition? Because you are sucking the air from the atmosphere and then you process the air inside the compressor and you are delivering the air again back to the atmosphere. That is called inlet condition. In the inlet condition, we are measuring the free air delivered, that is the volume. But this we cannot measure in our plant and other operations. So we can measure the plant by some other method that we can see later. This is being measured in manufacturers itself. So they will do some nozzle type method. They will measure. This is the compressor capacity. What is CFM? What is the milliliter per minute? This is the specification of the compressors which we are getting from the OEM or manufacturers. Okay, what is the approach to have an energy efficient compressor? What is the approach to have an energy efficient compressor? First, we need to select the right size. Already we have seen it. The second one, we need to manage dynamic system. What is dynamic system? What is dynamic? So dynamic, the name itself, that keep on changing because there is an intermittent or pressure drop is there, some demand is coming, volume is increasing and decreasing, some productivity increasing, productivity. So that is a productive based on the we are operating, we are supporting to productivity. So based on their demand, we need to operate the compressors in dynamic way. For that, we need to have some intelligence in a proper way. Okay, the road should be smooth like that. Our compressor air, which will be traveled through to machine shop or assembly line, to be smooth. Okay, and also the evaluate process. So coming back to this, we will select the right size. We will achieve the 20% energy immediately. Also, dynamic system, as we see the volumetric efficiency, we can vary the speed by putting a VFD or something. So we can vary the speed by achieving the efficiency part. But you can see by using the VFD, it will be more efficient than other methods. So there are many methods are available, but the VFD is the currently the most efficient way to do the dynamic system, because you can do some wonders by using VFD. Not only for a starting purpose, the VFD can be connected with the pressure regulator. That feedback can be given to the VFD. We can regulate the pressure. So based on that demand, so it will regulate automatically. So more precise VFDs are there, and this total set of arrangements will be very interesting if you go in deeper. And the smooth flow is nothing but in a supply side we have seen the pure air is coming out from the dryer and after that some filters. It will be transferred to the shop floor plant and for machine operation and tools requirement or medical, whatever, the piping is the very important. Piping is very, very important. Sometimes actually we forget about the pipeline system, pipeline distributions. Normally we tell plumber whether he is a subject matter expert or he know very well about or experienced. We just depends on the plumber. Whatever the size and whatever the make, whatever the specification of the pipe and whatever the piping structure and the distribution system and how many drain points are there. So we normally caring about that, but not much about it. So we need to avoid the winds. Not only this air pneumatic lines, but also the water flow lines. Also, it's very important. And also the dead end pipelines, which never be used in compressed air system, because if you have a dead end line, there will be a more pressure drop in the line. So piping in structure is another reservoir for this compressor receiver. It's like a receiver. There will be some volumetric is always there in the pipeline, piping distributions. So you can arrange in the fan type arrangements in the while distributing the pneumatic pipe to the different zones. Okay. And the last one, we are attacking compressed air elements, and also the other piping structure and like that. But we forget about the process. Sometimes process also matters. We need to evaluate the process, whether the correct volume is required or not. Suppose for paint applications, how many CFM is required? For grinding, how many CFM is required? So we need to evaluate the process. For particular machine, for an example, one CNC machine is coming. So what is the pressure is required for that? What is the volume is required for that? One assembly line, many pneumatic tools are being used. So what is the volumetric is required in that area? So you need to evaluate the process. Wherever the possibilities are there, you need to address that. After addressing the possibilities, opportunities, you have to do one thing. So you have to three categories you have to do the opportunities. One is the no cost. No cost means without any investment, you can do some maintenance activities. You can do some energy efficient operations. So that can be done. Some activity. And the second one is low cost. So by small low-hanging fruits. So that can be done immediately, because without hesitations, we need to do two things. So by some proper action plan. So what is to be done, when it is to be done, who is to be done, and how it is to be done. Like that, you need to prepare for all these three. And the third one also, we need to have some action plan in a detailed way. Some analysis needs to be made before investing there, because that needs capital budgeting. And also, if we are investing, there is a return on investment we need to look into, and also the payback period. Return on investment or payback period, which one is practice. So long-term durability also we need to ensure. Suppose if we want to, so say example, some device is there. So some supplier is selling that device. Sir, this device is going to help you. Energy efficient is possible. So we have achieved so and so much percentage of energy efficiency by putting. So we have implemented across the many plants in the cities. So if we come to sell to you, so you have to keep your internal analysis before you have to discuss with the experts, and also you discuss with your team whether this is practically applicable, and also what is the budget and what is ROI, and also the performance after implementing. Because actually, for interestingly, actually we will attract to the product and we will implement initially, but after that we will not have much support from the service part or some technological changes. And also the performance analysis we cannot do, or we cannot measure the performance like that. So that case, so it's very difficult. And also, if you're not measuring what is the performance before fitting into and after fitting this device, that will also be a problem. So by considering all this, you have to make a detailed action plan for this. As we see earlier, the compressor's installation, the energy efficient starts from the compressor's installation. Have you seen the compressor's installation area in every plant? Because the machine shop or power plants are there, but the compressor area somewhere in the corner area, it will be commissioned. After commissioning, no one will bother about it. Only maintenance people will go and come in that area. So sometimes that needs to be. It's not a problem, but we need to make conscious on that, because we have installed in that area. Is it a good environmental way? So that is dirt-free, dust-free, and enough space, because the maintainability is very important thing, and also the fresh air needs to be circulated in that area for proper ventilation and airflow. Then only the temperature, cold air, because air intake is the first point. That is the first step of energy efficient operation. That is the first step of energy efficient operation. So in that area, you need to consider all those things in the. Sometimes the compressors are installed in the lean set. Sometimes nowadays all the compressors are installed in the compressor room. So the compressor room should be neat, clean, and dirt-free and dust-free environment. And also the ventilation duct, if required, you need to arrange. Otherwise, so that hot air will be circulated in the compressor room itself. That will make your compressor inefficient. And also the place where there is a hot temperature, too hot and extremely cold temperatures are there, some processes there. That place you should not install the compressors. So this air intake, if you see, air intake should be cool. So every 4-degree rise in inlet temperature cost you much, because 1% will be the energy cost will be increased, energy consumption will be increased. And also the dust-free also, that will increase the 2%. So for every 250 water ton per second in the dust-free uptake. And also dry air, the moisture should not be there. That's what two cold areas that you need to concentrate. While coming to this pipe distribution, after installing the compressors, you will take the air to the plant and the machine shop assembly and the process areas. So the piping should be large enough because the pressure drop should not exceed 10%. And also the size of the pipe should be greater. The discharge wall you are providing, that should be greater than the discharge wall. And also the pipe should be galvanized. Suppose that many materials are being used, the black iron and the MS, this thing and the PVC, copper, aluminum, stainless steel, many materials are being used for the pneumatic line transferring. But nowadays, most efficient way is the aluminum. That is but the cost is very high. Cost is high. So if the air quality, if you want, because it depends on the application and depends on the process, so we can use the aluminum. Otherwise, we need a more manpower or resources to do the maintenance activities if we install the this MS and the GA pipes. And also the slope should be maintained in every area. Suppose we have different zones because we need to divide it into many zones for pneumatic pipelines. So this pipeline should be sloped away from the compressor. So actually some suppose every 100 meters there will be some 1 meter something you need to have some slope. Otherwise, there will be a moisture condenser will be stay on the pipeline. And also the drains. The drains you should install every point. And one more important point is that pneumatic line, you have to main header will be there and also the subheader will be there. Main header means you are distributing the pipeline from the main compressors through the plant. The subheader has to be taken from the top, not in the bottom. Okay, that also needs to be considered for the efficient operation of compressed air system. So as per safety standards, actually the PVC is not recommended in many cases. Normally they are not using nowadays, but anyway, the PVC should not be used for safety reasons. So another point.
उसी दिन आपने वो ये देखा था ना वीडियो
Okay, another part is the air receiver. So we can call air receiver as a in electrical terminology we can call it as a capacitor because it stores energy. Like that, it stores amount of compressed air required to raise the system pressure. Sometimes the pressure drops will be there in the far end of the plant. So it needs to be ready to lift the system pressure by 1 psi every time because this needs to be accumulated, right? And also it has to supply the current supply as well. The same receiver can be compared with in our hydraulic system accumulator or some booster, and also in the transmission of system, the flywheel operation like that. So when you see the air receiver pressure changes, suppose there is a slope can be determined. You can see from the picture, the negative slope indicates that. Suppose if you find negative slope indicates that energy is released from the air receiver. That is, compressed air is released from the receiver in order to raise the system pressure. Suppose the positive slope is that the energy is absorbed into the storage because it receives from the compressed air. Compressor, sorry. And we have seen this from the formula that volumetric efficiency, speed control. Speed control, sometimes we can do it in separate way. And also some reciprocating compressors and the multi-step control, speed control is available in the compressor itself. So there you can power consumption at various loads we can reduce. So even if you use 50% load and 25% load also, so you can benefit much benefit from the VFDs and some throttle controls, some pressure control like that. The speed control is achieving nowadays is only affecting through VFD only. That is the most effective way. Otherwise, you can do some internal retrofitting of air ends, because you can see the air ends, two rotors are there. So you can retrofitting of air ends, you can reduce the volume by resizing that components. Actually, one important point we need to remember while lowering the speed using VFD or VSD, lubrication should not be affected. But you should know that what is the base load or slow speed, very low speed. What is the base load? Base load CFM, that is volume. You need to fix it. Otherwise, if you reduce the speed very low, then there will be a danger to the lubrication system as well. And inappropriate usage, already we have seen it. So coming to air leakages. So actually, this is the from the table you can see the orifice size 0.8 mm, kilowatt wasted 0.2, cost only 9,600 per year. Yeah, right. But the multiple of 0.8 will cost you more. Even 9,600 also is unwanted one. So we need to take care of the air leakage management system. So we need to establish the air leakage management continuously, because one time is not enough. Because many service points are there, many induce points are there. So there are leakages in the pipeline fittings, valves, and joints, even in the equipments and tools, FRLs. So all needs to be addressed. Suppose if you have enormous, plenty of FRLs, plenty of joints, so you have to keep monitoring all the air leakages percentages or air leakage management through some effective system. Otherwise, if you do randomly, or if you do, suppose if somebody asks, you will do some huge noise is there. If you do, so that will not be effective. You have vigorously, consciously, you need to do some systematic thing. So if you have an engineer, so give it to him one managing point and performance indicator KPI. So give it to him. So the air leakage audit he needs to do. So this much of air leakage needs to be arrested per month or per week or every day. He needs to report like that. So that kind of system or some other system, ultrasonic detectors are available. So you have to use that ultrasonic detector as well, because sometimes we cannot hear the hissing sound manually. You can use that type of ultrasonic detector as well. So by putting proper tagging, so so this week we are addressing the air leakage audit. So I have find 100 abnormalities in the particular, for example, assembly line 1. I have found 100 abnormalities in the air leakage point. So I'm going to have an action plan for addressing this air leakage point. So these 100 points needs to be addressed, and also the next audit needs to be scheduled, because there should be some schedule for air leakage audit and also the countermeasures for air leakage. In the air leakages, in my experience, most of the air leakages are just do it cases, just tightening and some inspecting and tightening works only. So replacing one touch fitting, some walls, FRLs. So like it only, so most of the cases are there, 60, more than 60. Some cases are needs to be materials required, or some repeated leakages needs to be addressed in a scientific approach way, or some problem solving technique we need to address on it, or some technological changes also required for that. Right. And automatic on-off control, this is possible in the reciprocating compressors. In the reciprocating compressors, the pressure control, that is what cutting cut-off pressure, you can do it. But this automatic on-off control, I can share you one more thing. Suppose we are operating an assembly line and a machine shop and we are operating machines and equipments. Sometimes the set of tools in the assembly lines. Okay, after the end of the shift or during the tea break or some break beyond 30 minutes like that. So you can shut off the valve. You can shut off the valve using the electrical control. Some auto shut off valves are available. You can program it or you can do some electrical circuit on this. So we can do things. Suppose if the more pilot valves are available and the timings are different, you can do some PLC logic. Small micro PLCs are available. So you can install one micro PLC and you can connect all the pilot valves in the different, you can program in different timings and different patterns, and also the real-time clock also you can set it, weekly timer also you can set it in the start. Suppose your plant is not operating on Sundays, you can shut off it's Saturday end of the shift at 5 o'clock. So you can set a program on it. So this can be done in a centralized way, also decentralized way, or wherever applicable. And also if there is a volume is more, and also if there are the places where the leakages are more frequently, so that place can be analyzed and you can implement effectively. That can be possible. Okay. So next coming to the air leakage test part. So this air leakage test we can do even without knowing compressed air or something. Any one do some Excel sheet and you can do the air leakage test as well. Actually, how do we conduct the air leakage test? It's very easy. This needs to be done in the holiday only. First, in the power plant, it's very difficult, and the continuous process industries somewhat difficult. Somehow, we need to do in the shutdown time or in the zone. We can separate the zone or do some exercise on this. So zone wise also we can do some air leakage test also. But its effective way is only shut down all the machineries, equipments, tools, wherever the compressor is connected, service points, as it is. So do the repeatable test for 8 to 10 times. Minimum 5 to 6 times minimum is required, or for better accuracy or for better things, you can do 8 to 10 times one cycle. If you do that, you can have one formula that the total loading time you can measure and then unloading time you have to measure. So based on this formula, this load time divided by total load and unload time. So multiplied by 100, you can get the percentage of leakages. Okay, and also if you multiply this with the volume, you can get the what is the leakage quantity in the plant. You can get. Actually, normally the industry's benchmark 15%, less than 15%. But that is also not fair, not good, actually not advisable. So if you less than 10%, that will be very good and excellent. So if you address more and more, because for that only air leakage management system should be effective and robust system is required. So if you address more and more air leakage management, so you will be finding more opportunities as well, and also you may implement more automation in this, so that your hectic will be completely disappear. So one example I'm just putting, this is coming the 6th repetitive cycle. See this 26.13% leakage is coming. I'm just putting the same time. Sometimes it may vary. For illustration purpose, I'm just giving this time, and also the unloading and loading time may differ, compressor to compressor and application wise. Okay. Based on this, you can find from this leakage, you can find what is the volume is wasted per day and what is the specific power consumption of the compressor. That also you can find from this leakage test. You need to do you have to schedule this leakage test and can be applied effectively. And also the line moisture traps is very important. Sometimes we are not concentrating on the traps and the drain lines. So every 30 meters, there should be some drain. But condensed water will be drained, and also the rust and dust particles and particulate matters will be deposited in the drain and will be gone out. So you see this galvanized pipe, GI pipe. There will be some so much rust because of this volume of air will not be there in the pipeline, so that you have to generate extra compressed air. For that extra compressed air, you have to run the compressor, so that energy cost will be more. So this is a it's a very common sense that we need to do some drain every 30 minutes at least. Okay, the drain, if you provide a drain, so who will be draining the pipe? That is the one problem. Suppose in the main receiver, air receiver, if you have a drain pipe, so some person will go daily and he will drain. But in the plant, a very big plant, so suppose hundreds of drain lines are there, so who will go and do that? And also this unattended areas will be. So for that, you can make there is a timed electric, that is a timer controlled drain. You can set it. And also the demand type, that is very costly comparing to the timed and the manual, that is costly. But also, suppose if you want some quality of air is more prices and conscious of the quality of air, you can do the demand type drain one, because that is drained based on the moisture level and the water level in the drain area. So when coming back to this case study, I'm getting this published only. This is for illustration only. It's not exactly this type of compressors and other things. Okay, this optimum utilization, because unloading time we need to minimize. So that is the first part. Actually, that 37 kilowatt compressor, if you are having, so unloading is 70%. The requirement is somewhat some CFM is there. So for that you can do, so the unloading percentage is very high, more than 70%. You can have another 15 kilowatt compressors. So whenever the demand is high, so you can use the 37 kilowatt. Whenever the demand is low, you can use the 15 kilowatt. Or you can resize both the compressors with the, suppose if the demand is high, you can run both the compressors. If the demand is low, only one compressor. That kind of thing you can do. So this payback almost 12 to 18 months, within 12 to 18 months you can get it by proper calculation. The second one is in a textile industry, and also when yarn breakage time only the 600 CFM is required. Remaining the time only 100 CFM is the requirement. So for that, they have oversized the compressors. 600 CFM compressors they installed. So that time, so the same thing. So 125 compressor is enough. So only when it is a 600 CFM is required, you can do some pressure controlled arrangements, some VFDs or something to have it. This one is another many areas. This has been implemented in many industries. They have implemented this kind of thing. So there is a two machine shops are there, and a separate machine shop they have a receiver and another receiver. So two compressors. So for that you can interlink both the receivers. You can have volume. You can increase the volume so that you can meet the demand. So based on the demand, the compressors will be operating. So if you want, you can operate the single compressors, keeping one is a standby and one, or you can operate both. You can resize also, because the continuous study on the loading pattern, you can do some investment on this. This is one in a paper mill, waste heat recovery. We saw in Sankey diagram that is 72% of heat dissipated in the oil cooler. So the waste heat recovery is installed between the compressor and the dryer. Sorry, after cooler. So if you place this waste heat recovery, so this waste heat recovery can be utilized. That heat dissipation can be utilized for preheating because the power plants, the boiler operation, wherever there is a preheating, feed water is required. So that area you can utilize this waste heat recovery, and also the hot water is required for some processes. That also 80 degree you can, it is possible because 60 degree air temperature is there and 80 degree oil temperature will be coming out from the compressor. So you can make utilize on this. So it's very effective one because very effective one, and also your much energy can be saved using this. For example, in paper mill, that's heat recovered is 89.4 units per kilocalories. So almost 2,000 liters of continuous water supply is going through this waste heat recovery and getting heated and is being used for the processes, their processes. Another case study, if you're coming to VFD as well. Here, the requirement is almost total. If you see the diagram, there is a 497 is the base load of the compressor, one compressor. Suppose the constant volume, and also another compressor also 100 HP compressor, that is also 491. So 497, sorry, 497 plus 497, 994 is the, if we operate two compressors, constant volume 994 CFM can be met, the requirement can be met. Suppose below 497 and also above 994 and also between 494, 497 and 994. So we need to think in differently. So we cannot use this constant volume compressors. For that, what we do, we need to find it out this control gap. That control gap is everywhere. The demand pattern, if you analyze the demand pattern, that the control gap is there. So if you analyze this control gap, so you can install 150 HP variable drive, variable frequency drive, so that their maximum flow is 735 and the minimum flow is 150 CFM. The 150 CFM is the volume we are getting at low speed of the compressors by using the VFD. So you can vary and you can regulate the pressure within this control range. See this, suppose if you want 1225 CFM requirement demand is there. If you regulate the pressure using the closed feedback or connecting the pressure regulator with a VFD or master controller, some master controller for both three compressors are connected together. So then you can sense that the demand is coming out. So that based on the demand, the prediction, you can switch on this VFD and you can support it as well by varying the speed. So by the way, this 735 and also between 497 and 94, you can achieve it. So you can regulate up to this control range between for the VFD is 585 CFM because that is the maximum is for 735 and the minimum is 115. So we are supplying only 231 CFM for that. So this is also one case study. Depends on that. So why we need a constant volume machine here? That is the question. But depends on the application, as it were. Depends on the application and requirement. You need to decide whether the VFD control is for one machine or two machines or all the machines, or you need to connect through the master controller. So nowadays, many master controllers are available from the manufacturers itself or separately they are doing. So that master controller using this master controller VFDs, compressors can be connected. This one is for illustration. Just want you understand the energy, how energy can be optimized. So this can be done for this logical can be done for any machines, any equipments, and any assembly line of whenever it's applicable. So suppose an equipment or the compressor utility. So energy meter is fixed in the compressor or this particular machine. So nowadays the energy meters are coming out with a relay output and also some triggering relays are there. In this, this is one type of energy meter which has the potential field contacts and also which will trigger the relay outputs. So if we set the minimum current setting or maximum current setting, we can have a control on the equipment. So this we suppose, for example, one machine, you consider one machine with a 100 kilowatt machine. So in that, suppose in the machining operation or some operations, it needs to switch on continuously. After machining operation or during the lunch time or sometimes, that machining operation, it will take high current, but during the idle times, that means no operation, no machining, there will be no energy. That time we can sense using this energy meter, and also we can set the no load current. So that is the no machining, no, not no load. What is the current during the non-machining time or non-operation time of equipment or non-operation time of assembly, like that. So we can have a setting on that. So based on the setting and the time, suppose if the operator is not timed off for 20 minutes, you can set off the system not entirely, but the emergency circuit can be switched off. So you can save some energy, because especially in the machines, you can save the energy enormously. So in my experience, some 9% of energy is being saved, because that hydraulic and other chip conveyors, other machines are running continuously. Even if you are machining or something, some other operations, it is continuously running. That can be addressed through this configurations. That's what I want to share with you, this thing. Even this can be applied to the compressors. In the compressor panels, if you have a unloading operation for so much time, so you can trigger via this segment as well, apart from the pressure control. And one more thing I would like to share in this point, significant energy use area. You have to identify, so compressor is one of that. In our plant, so you just segregate the energy zones. There is a significant energy use areas. This one of the zone or one of the SUU is compressor. You can make it SUU, one of the SUU as compressor. So based on that, you can make some mini SUUs. Then only you can know what is the energy intensity in each SUU, so that you can find an opportunity, and also you can explore the possibilities to execute the opportunities. That way you can initiate the actions. So this is a very old practice that some I've seen on gear manufacturing company in Rajasthan. Their assembly line, many pneumatic tools are being used. Sometimes the process drop is inevitable in that area. Suppose many different tools, pneumatic tools, have different CFM and different process requirement. So that area, they have stabilized with the pressure regulator. Sorry, booster, pressure regulator as well as the air booster. So that will help in the particular line or particular zone that can enhance the pressure, so that our initial pressure compressor cannot be regulated to the maximum. These are the factors influencing significant energy consumption. So why these factors are increasing? Because so after implementing so much initiatives, after exploring and implementing so much possibilities, you have to monitor. You have some controls on it. Performance control, performance measurement should be there. So for that, you need to monitor some of the parameters. So some factors we know that electrical supply, definitely the supply should be actually we are monitoring regularly. So this is the one of the factor, and power factor we know very well. Power factor is also one of the factor in deciding the energy efficiency and the earthing system. Double earthing is compulsory, and also that earthing should be effective, and also you need to compliance part. You need to based on the requirement, you need to schedule the earth pit or something earthing point calibrations that needs to be done. This is also compliance part as well, and also motor performance. You need to continuously monitor full load current and rated speed, and what is the no load current. So in doing preventing, not only in preventing, you can do continuous monitoring as well. So nowadays the systems are technologies are coming very good. And the vibration level is also more important for a breakdown as well as other factors also. Air leakages, we have discussed more on that. And one more, the exhaust fan is available in the compressor for oil cooler, for air cooled emissions. So that also need to be addressed, because sometimes that even exhaust fan is not working or not in an efficient way. So that will consume more energy. So even if it is a 5 kilowatt or 10 kilowatt or 3 kilowatt, that is also matters. And the cutoff pressure, that is a very important point, because that range so always they're setting in a very broad range. So you have to study the pattern and also study the requirement of the process and the product requirements. Then you decide the cutting voltage, cutting bore, cutting pressure, and cutoff pressure. And also you have to decide the frequency of monitoring and how you monitor. Is it online or offline or manual? So through air audit or visual inspection is required, or also using some instruments that needs to be decided. This kind of chart. So if you do technically well, so then there will be a proper energy efficient is possible. This is some tips. Apart from this, the same thing, you have to reduce the pressure, because whatever the requirement, there is a pressure. Filters, changing the filters on time, because we are very much negligence on the filter part, because okay, what is the connection between these and energy efficient? That's what we think, because in a tube, suppose in our room or house, we simply replace the tube light. The light is not enough sufficient, so adequate light. So lighting. So I'm replacing the tube light with 30 watts, 22 watts, like that. We simply replace the light, but we need to one thing. We need to just clear surface, cleaning the surface of the tube light. Then you will get more illumination. Without doing that, we are simply taking some decisions. So that is more important. And light dryer, DFD, and missions of air. This already we have seen, and also air audit. Air audit definitely, as a power plant and any manufacturing industry, you need to do air audit regularly. It's a air audit is also part of energy audit. Suppose if you're not affordable to the whole energy audit and also the frequency, so you need to do air audit regularly. So that is very, very good practice for that. And apart from this, good maintenance practices also will keep us in the front sheet of energy efficiency, because we do reactive maintenance. There is a downtime maintenance that will help to availability of the machine, but that is a very old-fashioned, old conventional method. Nowadays, apart from the preventive and the plant maintenance, now predictive maintenances are coming up. Already implemented some of the areas, and also some research is going on to do some algorithm on the predictive maintenance. So now the management system and the dashboards are available. Sometimes they connect the pressure and so many sensors and taking the metrics and then monitoring. That is the predictive maintenance. Nowadays they are saying many suppliers, but it needs to be in the. I personally feel that it is in premature stage. It needs to be improved a lot by developing a accurate algorithm in that. So that means, so you need to predict the failure before it occurs. For that, you need some data and you need some metrics, some points. You need to have some sensor, because the main challenge is providing sensors in wherever we want it. That is the problem. Suppose one velocity is required, some angular velocity is required, one part, some field rate is required. these are all some deciding factor, some factors influencing the breakdown or some vibration. So we cannot. So we simply taking the current voltage, power factor, whatever the possible way of doing providing sensors, we are taking out right now. But definitely there will be a breakthrough after in the algorithm part. And oil sampling, you need to get the oil report because the moisture and this that you need to do regularly or some scheduled way. And shock pulse method is one of the method for diagnosing the metal impact, metal of the gear and the bearings. In this, you can do that's condition monitoring. The shock pulse method is also one of the condition monitoring. Condition monitoring, vibration, that kind of test you can take regularly during preventive maintenance or planned maintenance, or you can schedule the condition monitoring with the experts. And FAD assessment. FAD assessment is actually the nozzle method we cannot do in our plant, but you can do some FAD assessment after long time, because after 5 years or 7 years or 8 years, so you can do FAD assessment. That is nothing but there is a formula. And the leakage management system. This also we have discussed in deep. So this is the capacity test. I think the formula is very far. P2 minus P1 by P into volume of air receiver by delta T, time taken for charging the receiver, because time taken to fulfill the fulfilling the air in the receiver. So P2 is the final pressure, because that is the pressure you are achieving from the time when you start the compressors. So these are the some more points for effective energy efficient compressor system. The aerobic process, I'll just go through quickly because this is the very big subject, and also the aerobic process is also a very big one, and also more important has to be given to the aerobic process, because you need the monitoring of the plant utilities, and also you have to measure the flow of flow requirement for each zone or entire factory or entire plant or equipment wise. If you have plenty of data available with you, you can interpret easily. The data is matters, because that aerobic, if you do consciously, so it will be good. And after that aerobic, there will be opportunities identified. That opportunities can be analyzed with the resources and requirements. Then the recommendation can be done. So actually, using the aerobic, you can save the wastages. Many case studies you can see in the online, and also many case studies are available. So even first they have ordered one compressor for so much kilowatt. Then they realized that this is a very oversized. After conducting the aerobic, then they got back, because even after releasing the purchase order, they have shifted their compressors to some other plant. So that kind of potential is there in the aerobic one. We should not miss out the aerobic in our plant. So there is another one, it is the supply and demand, because what we are expecting from the compressed air system, what we are generating the compressed air, that needs to be kept in the machine shop assembly line, the end user. So that is the process. That is the thing. So some dew point analysis, volume flow meter, installing volume we can measure daily, and we can make a reading and recording daily. And also the leak direction, piping schematic. Piping schematic you can do with some experts. So that is very important thing, but there is a negligent part in many industries. And also instruments. So what are the instruments? Instruments also very major part. A key role in deciding that, because if you use effective and more accurate instruments, that will give you more data and very accurate data, so that you can analyze, interpret, and predict the possibilities, opportunities, and the failures. So if you don't have the proper instruments, that will be a problematic one. This is one kind of aerobic proposal in an industry. Some assembly lines are there. What are the base load and the variable load and total load is there? What are the point of use? Machine applications, service applications, how many machine points are used, and number of operating hours per day, these are the data collected and based on the selection. So for that, they have a proposal that for instrumentation, they will have some separate requirement. Service application, they'll have a separate application. So based on that, they have recommended the compressors for their use. Based on the savings, will be more because more than that, predicted savings is coming. We know that. And coming back to this approach, actually, while thinking about the energy efficient operation in any, not only in compressed air system, so we need to think of basic components of that particular machine or equipment or system or assembly, for which we need to do some correction in the energy efficiency. And also the theoretical part also we should know some formulas, some basic formulas we know. We don't go in detail. Sometimes it will be, so by doing these things only you will drag the time. Sometimes practical, be practical on the energy efficient part. Sometimes be practical means you need to apply. So if you are in a theoretical part, if you do the again the calculations only will not help. So you have to make some action plan. What is to be done, how it is to be done. So what is the risks and what is the mitigation for that? So you need to do. So for that, this is the approach where everywhere this is for doing any activity. Even your personal life also, this principle can be adopted. Plan, do, check, act. PDCA cycle. That is the most popular approach for any problem solving and also task achieving and also do so many actions. So for that, you have to plan the resources and also the energy data, and what are the aspects in the particular equipment. So energy aspects also you have to consider, you have to analyze each and every. For example, compressor, we are just compressor output volume like that. You have to go in deep detail that inside the compressor, what are the elements are there, what are the energy aspects are available. So in the energy aspects, how can you contribute the energy efficiency part? That also you have to analyze deeply. So even you can't, you may be surprised. Even the small element that will be the trigger point for the energy efficiency. So this we have seen in many cases. Planning, energy planning. So that also very important. Energy planning means, suppose by only doing the activities will not help the energy efficient way. So you have to do some data analytics. By data only it will not help. You do some metrics, performance indicators you have to set, some baseline you have to set. You have to monitor the baseline, you have to monitor the performance indicator and also the operation controls. So this operation control, suppose for example in a CNC machine, pressure regulator, there should be some 5 bar pressure should be there. This is an operational control. So if the operator raises the FRL to 5.5, what will happen? This will accumulate the effect in the total energy, total compressor energy. So you have to keep on every data, every monitoring of the performance indicator, baseline. You have to set a metrics. You have to set a standard for it. So unless otherwise, this all comes under the energy planning. And also you have to do some energy review also. After 1 year, you have to review the energy. So what we have done and how we have achieved and what is to be done. Is there any extra process is added or any process improvement is there? Any machines has been removed? So like that analysis we need to make for the energy planning. And the do part, whatever you plan, you have to do. That's all. The training, implementation strategy, and also the performance indicator also you have to set it. Whatever you plan the performance indicator, you have to set it for the in all levels, not only the supervisor level, manager level. You can even set it to the assembly production line also. And the check. So check is the, we are just checking the what we have done and how it has been, the result has been coming. So for that you have to do some audits, measuring and monitoring schedule, like that you have to. And also if there is any problem in the do part, suppose if you are doing some work actions, if you are taking some actions, the actions is not enough, so you can do some corrections and corrective actions can be done for that particular. because it's not necessary to implement what we have done in the planning part. The second one, the last one is the act. So whatever the monitor we have monitored, whether we have achieved our target, whether we have achieved what we have planned, so that needs to be reviewed, and then we need to take action against them. This cycle is going to be repeated for a best results. So in management, there is definitions given in the right on a series of activities that plans and controls the daily work. We have to plan and controls. So in order to achieve the objective in most efficient and most effective way, by keeping balance between quality and quantity, this will applicable to energy management as well, or energy efficient operation as well. So you see the diagram, the PDCA cycle is rotating, the wheel is rotating up to till achieving the goal. This is not only rotating in the one time. The standardization has to be done, because every time if you do this PDCA, there will be a learning for you. That needs to be standardized. For example, if you do some correction in the equipment, you need to record it on the history card. You need to record it on the some check sheet you need to provide, some standard operating procedure you need to provide, some operation control you need to monitor. If there is any changes in the operation control, you have to update it. So this is the standardization. PM check sheet, preventive maintenance check sheet, condition monitoring. Suppose if you are establishing condition monitoring, you have to schedule for the condition monitoring, calibration schedule. These are the standardization products. Till you achieve the result, energy efficient operation, as per your planning, you have to keep on fine-tuning that. So this, without data, you are just another person with an opinion. Actually, the data is more important nowadays. We believe in God for something, but in engineering, major decisions are being made using the data. And also in future, data analytics and data science is also one of the subject in every area that people will be going to learn and study. It's a major area because artificial intelligence are coming out in an effective way. So the data is more important. The data manipulation, the data algorithms, these are all will be a critical role in playing the energy management, not only energy management, process automation and everything. So industry 4.0 is the new era nowadays. So we need to move on the Internet of Things, IoT based energy efficient operation or IoT based operation. While selecting the compressor, while selecting the compressor components itself, we need to be very careful whether there is a communication device inside the sense that dryer or compressor. In the compressor itself, the manufacturer themselves they are giving IoT type. If there is any compatibility is there for connecting with our own IoT, future expansion possibility is there. If there is any changes in the software or changes in the module or algorithm and the connection part, these are to be evaluated before investing any component, compressed air components. So this industry industry 4.0 Internet of Things is in a premature, even if it is in a premature stage. So many industries are implemented in their own way. See, as I said earlier, sometimes this HMI and this gimmicks of this dashboard is nowadays playing a role, but we should not see the dashboard itself. We need to see inside there is an algorithm and what are the alerts we are giving, what are the features we are giving, how we are predicting the failure, how we are monitoring the critical parameters, significant energy use areas, how to identify, how to make analyze using this data. All these things we need to get it. So some of the performance indicator I am giving this. So kilowatt per CFM, that is one thing, and also or kilowatt per 100 CFM can be set. This also monitored using the Internet of Things. In IoT itself, you cannot go and measure every time. So this needs to be automatically come in the morning or every 5 seconds, every 10 seconds, every 10 minutes, every day, every month. The all details will be available in the IoT because that is the critical part. That is a very effective part. And also the specific energy consumption. This is the most important performance indicator. Energy performance indicator, because for what we are using compressors, for what we are producing the compressed air, generating the compressed air. for making the output, plant output. If you are producing a product, your production is a one refill pen, or if you're making one notebook, if you're making one cell phone, this is the product. For making one casting, that is a tonnage. You have to correlate with that energy with that output. For example, in foundry, kilowatt hour per ton. If you are producing a pen, kilowatt hour per 1.1 pen. So like the kilowatt hour pen per product, you have to make it very sensible on this. Then only you can have a effective control on the energy efficiency initiatives. Otherwise, that will go in some other way. So like that tap water, there will be leakage in some other way. You will get water in the tap. But if there is any leakage in the pipe, that will go in some way. You cannot know. So this part, there is a denominator and the numerator and denominator. So numerator is the kilowatt energy and denominator is the output, production quantity or output of the plant. Suppose if you are producing energy, kilowatt hour, how much in a thermal power plant? If you are producing this much kilowatt hour, gigawatt hour, so you can relate with those. So for 1 gigawatt hour generation, how many units are being generated in the compressor? Consumed, sorry, not generated. How many units consumed in the compressor? So that kind of performance indicator will help you to more focus on the energy efficiency part, because this is an there will be independent variable and independent variable, both in this case we see. Okay, based on that, you can have some analysis as well, because the regression analysis is most popular in the energy analysis. You can use that, you can correlate with the production and the energy. So if the correlation is well and good, you can proceed with the analysis and initiatives. You can enable the drivers and the percentage leakages. But even though there is a benchmark, somewhere it is given 15%, so we need to less than 10%. We need to concentrate on this. So this is the IoT. You have to concentrate on very well, and also you have to learn IoT, because that is the future of the industries. Okay, coming back to our routine life, sustainability is more important, because nowadays sustainable development goals is being initiated through United Nations. They have set a target to each country and everything, because many people are not aware of this, but this is our plant. So we need to contribute as an individual, as an organization, as a group together. So in this part, if we save 1 unit of energy, I think group people in a thermal power station or power generation teams knows very well about that. For generating, so in the household person, if we get 1 kilowatt, for getting 1 kilowatt hour electricity, you need to generate almost 4 to 5 units of density you have to generate. For that, you have to fossil fuel burning. So that much, so you know very well. There is a big subject. I cannot go on this, but we have to do something for the planet in this way. Not only in the energy efficient way, we need to keep always conscious on the environment part as well while thinking about the energy. So that's all from my presentation. Hope if there is any speed on this, I just want to complete on time. That's why I just go through. There are a lot to share my knowledge and experience. I hope you will get more insight on this energy efficient operation in compressed air system. I'm very passionate about sharing my knowledge and experience in various topics like TPM, TKM, electrical safety, maintenance management, QC stories, and TKM, the area of engineering science, in the power systems as well. So I hope I really enjoyed this session, and more importantly, I would like to thank Dr. Venkata sir and Dr. Shyam and Maheshwaran also for coordinating this event, and they have doing some fantastic work by having some productive sessions throughout this week. Thank you very much.
Thank you very much, sir. Such a wonderful presentation we received today. And participants, if you have any queries or any discussion with our expert, you can discuss now.
Since you feel if any is running short of time, I have my mail ID, so you can contact me. You can send the doubts or any clarifications. As far as I know, I'll update you. If any clarifications, you can call me also. I'm ready to help you.
Sure, sir. Yes, sir.
Sir, with respect to the free air delivery test,
Okay,
whether
sir.
we have to keep the nozzle at the compressor, for example, if the compressor has two stages, a low pressure stage and a high pressure stage, we have to
Okay,
keep
sir.
the nozzle at the outlet of the compressor. That means, or with respect to intermediate stage, we have to keep it, sir. How is that tested?
No, the end only. For FAD measurement, you have to keep the nozzle at the end of it. That needs to go to the atmospheric.
Okay, but
Because
during that test, yes, sir.
discharging air should be, again, we are getting the air from atmospheric and also we are sending back to the atmospheric. That inlet condition we need to maintain.
Okay, but
Also,
in
there are
that case,
some,
what
bulk
exactly
based
we are measuring
methodology.
here, sir, in the free air delivery, in the free air fat test? Like
Okay,
in the
sir. What
the
is it?
fat test, what exactly
Yeah.
we are measuring there actually by doing that system? By doing that procedure, what exactly we are measuring, sir? Whether we measure any flow rate at the end of the nozzle?
That is the capacity of the compressor, sir.
Okay, okay.
We are deciding this compressor.
Thank you, sir.
This will deliver this much volume of air. Sir, suppose one compressor, you can say 100 kilowatt machine compressor. Suppose we specify some CFM in the specification sheet, data sheet. So we need to validate whether this CFM is going to this compressor will be delivering this CFM as per the specification sheet. That test will be conducted at the factory in FR by every manufacturer.
View analysis ல இருக்கும். அதை நான் எங்கேயும் பார்த்தேன்.
Hello, madam.
Sir, thank you for your query, sir. Thank you for your.
Yes, sir. Any other queries from participants? No, right. Okay, sir. Thank you very much for spending your valuable time with us, sir. Thank you very much.
Thank you very much. Thank you.
Participants, I have shared the feedback link in the WhatsApp group as well as through your register email. So please submit that. Thank you. Yeah, so next session will resume after the lunch break. So you can rejoin at 2:30 p.m.
So please give me the feedback also.
Yes, sure.
Which area I need to improve so much better. Hope.
Yes, sir. Sure, sir. Sure.
Thank you, Mananda. Thanks for your time. Thank you.
Thank you, sir.
Shall I leave, Shyam?
Yes, sir. You can leave.
Thank you.
Thank you, sir.